Good morning. This is M. Paramesh, convener of 5-day online faculty development program on recent advances in electrical and electrical engineering. Welcome you all for the second day session. On behalf of Department of Electrical and Electronics Engineering, Gate Switch of Technology, I thank each and everyone for your positive response for day one session. I hope you all had an interesting and knowledgeable session on day one on importance of power system research in the development of society by Dr. B. Muruganandam sir. It was an excellent research topic as mentioned by our chief guest, Professor Sujata Madam, Principal, JNTU College of Engineering, Anantapur. And I hope all of us get new research ideas by the end of this 5-day FDP. Now it's time to kickstart of our today's session. Now I would like to request Ms. Reshma Madam to introduce today's speaker.
Good morning to all. I, S. Reshma, Assistant Professor, Department of Triple. I take this opportunity to invite an intellectual personality and today's our speaker, Dr. Chilaka Ranga, born in Malpur, Andhra Pradesh. He received BTech degree in Electrical and Electronics Engineering from Bapatla Engineering College, Andhra Pradesh. In 2010, he received his MTech degree from National Institute of Technology, Hamidpur, India in 2012. Also, he completed his PhD from the same institute in 2018. After that, he has joined in NIT Srinagar as an assistant professor in the Department of Electrical and Electrical Engineering. He has published more than 35 papers in various reputed journals and conferences. He guided 11 UG and 3 PG students. 2 scholars are pursuing PhD under his supervision. He has completed 2 research projects in the area of power transformer diagnosis. One of his patents was granted by Australian Patent Office. Another patent was filed in Indian office. His area of interest include performance evaluation and health assessment of power transformers, AI techniques, HV engineering, etc. He is the member of IEEE and IET. Also, he is the facilitator for IET on campus NIT Srinagar. Thank you so
much. Yeah, can I start, sir?
I welcome Dr. Chilaka Ranga Garu to take over the session and enlighten us with this experience. Thank you, sir.
Yeah, thank you, sir. Thank you very much for the nice introduction as well as for inviting me to this 5 days online FDP on recent advances in electrical engineering. Let me maximize the screen first. This one. Achha. So, is it visible, sir? Screen, entire screen, slideshow. Hello.
Yeah, sir.
Is my presentation visible, right? Okay.
Yes, sir.
So the today's session is on recent trends in condition monitoring and fault diagnosis of power transformer. So we will see the basics of condition monitoring of electrical machines and the recent developments and the recent technologies through which we assess the health of the as well as monitoring the status of the transformers as well as electrical machines, right? So introduction, particularly we will focus on power transformer, right? The condition monitoring of power transformer. And at the end of the session, we will come to know the recent trends in all the area, all the electrical machines, right? Condition monitoring of all the machines. And particularly we focus on power transformer, right? The area is the techniques are common to all the machines, right? Monitoring techniques. So we'll focus on power transformer. We know that transformer is an important component of electricity transmission as well as distribution, right? And once if you find any failure in power transformers, it leads to huge interruption in power supply, isn't it? So various failures slow down the age of the transformers. We know the various causes, right? Which degrades the life of the transformer. Transformer abbreviates its life than its expected life due to the oil and paper degradation, right? So if you observe the main diagnostics of transformer, right? There are oil and paper. So due to the several stresses present in general, right, develop in transformer, they degrades the performance of the insulation, right? Which is the heart of the transformers or any electrical machine, right? So due to these stresses, the effective life of transformer decreases, rapidly decreases. So starting from early 20th century, many studies have been conducted on the aging of the various electrical machines and the various operating stresses present in the electrical equipment, right? So so therefore the health assessment of any electrical machine is very, very important, right? We all know that we all know the the working principles, the design, the performance of all electrical machines, right? Being an electrical engineer, but the most important part is monitoring, right? We should monitor the machine, any machine effective, right? So that we get the best output from the machine. So monitoring is very, very important, right? So it's also our duty. Being an electrical engineering, we should know all the techniques related to condition monitoring, right? So if you talk about the transformer, mainly there are two installations, right? So condition monitoring, right? So it's right. So in any electrical machine, insulation is the heart. We know that. So if insulation works effectively, so definitely performance is also very well, isn't it? Right. So we should focus morely on the insulation, oil and paper, right? And we know that paper provides the insulation between the electrical parts, right? And right, we wrap the paper on the winding, right? Once the winding is heated, so this paper absorbs the heat first, and right, so remaining heat will be absorbed by the oil, isn't it? So we know the function of oil and paper and how they work, isn't it? We know all those basics. I will not go into that part, right? So I will touch the monitoring part, right? So if you look into the an isolating ideal insulating material, so they should have high dielectric strength, they should have high resistivity, good thermal conductivity properties, moisture should be right, the insulation should be moisture free, they should be chemically inert, they should withstand these right different vibrations, and right. So if you talk about the oils, there are different oils, right? Varnishes as well as oils, refined oil, silicone oil, ester oils. There are n number of oils, right? We can use them in transformers. But if you think about in economical point of view, we prefer generally mineral oil, right? So it is cheaper in cost and it gives the best for operating performance, right? As compared to the other oils. However, a lot of research has been going on, right? It's right in this area. So we'll come to notice all those trends by the end of the session. Similarly, there are so many developments in the paper insulation, right? We have fibrous materials as well as impregnated materials. Generally, we use kraft paper, right? Upgraded kraft paper as a solid insulation in transformers. Not only transformer, in any electrical machine, right? So these are the characteristics of an ideal insulating material, right? Solid insulation. So these values are with respect to the Indian standard 9335, right? So the reference values for a good insulating paper, right? Solid paper. So it should have thickness, apparent density, right? Electric strength, BDV, moisture content. Okay. So these values may vary a little bit according to American standard as well as IEC standards. So similarly, these are the various characteristics of oil insulation. We know the importance of oil in a transformer, right? It has a significant role, right? So BDV, neutral, right? Oxidation stability, pour point, flash point. We will come, right? We will discuss each and every point in later slides. Right. So if you talk about any electrical machine, so insulation is very, very important. So condition monitoring matlab, we should monitor the performance of the machine, right? So performance mainly depends on its heart, right? That is insulation. So if you talk about insulation, we have seen the characteristics of ideal insulating material. In case of transformer, we have oil as well as paper, right? So we have seen them. Now we will focus on aging, right? What is aging, right? So transformer age is an important factor to consider when identifying an expert to replacement or rehabilitation, right? During transformer life, structural strength and insulating properties of material used for support and electrical insulation. So aging is generally as per the transformer is generally designed up for 50 years or 60 years of age, isn't it? So due to the various operating conditions and different faults present in the system, they degrades the performance of the insulation, right? So that is aging, isn't it? The insulating material loses its operating performance, right? So aging, right? So there are different causes for the aging, right? So there are mainly 5 to 6 stresses which degrades the operating performance of oil as well as paper. So how these stresses develop first inside the machine? So that is first thing we should know, right? So the various causes. The first stress is thermal stress. This, right? We all know that under overloaded condition, any electrical equipment, any electrical machine, right? Under overloaded conditions, under faulty conditions, the winding gets heated, isn't it? Right. So if you run the machine, if transformer beyond certain temperature, definitely the material, the winding or the other remaining parts, they lose their operating performance, isn't it? So thermal stress, temperature rise, right? This is very, very dangerous situation in any electrical machine. So we should reduce the temperature with some cooling system or some other technologies, isn't it? Otherwise, the material loses its properties. If insulation gets failed, so definitely the life, the total machine gets burned, isn't it? Which leads to a huge loss to the utility as well as the customer, right? So thermal stress is the major stress. So we should focus on any in a research area, right? Research, we should we should design a good insulating material which can suppress these stresses. Next dangerous stress is electrical stress, right? We know that there are different conducting parts in every electrical machine, and we find these generation of electrical stresses, right? We have low voltage winding as well as high voltage winding in transformer, right? Primary and secondary. And there is a possibility of formation of current between the windings as well as body also, right? Frame, yoke, core as well, right? So we keep some, generally we keep this insulating paper or press board between the two electrical parts, right? So isn't it? If you don't keep these insulation, so there is a electrical stress and there will be a short circuits between the windings, isn't it? So these two are major stresses, thermal stress and electrical stress. These two stresses degrade the performance of the insulation as well as the overall performance of the electrical machine, right? Any electrical machine, not only transformer, any motor, generator, right? Rotating machines, DC, AC, right? In every machine, we find these insulating materials, right? So the minor stresses are chemical stress, climatic stresses, optical stresses, right? So, but their effect on the performance of the machine is very less. So the major two stresses are thermal stress and electrical stresses, right? We know the reasons also. So due to these stresses, developing these stresses inside the transformer due to various conditions, overloaded conditions, faulty conditions, short circuits, right? So we observe these stresses definitely, right? In practically we observe these stresses, right? In at different levels, right? In different transformers. So definitely there is a reduction in the performance of the insulation, right? Of performance of insulation, nothing but performance of a machine, right? You can understand like that, right? Because insulation is life of insulation is nothing but life of the transformer, right? Right of transformer nothing but life of its insulation, right? So we should know the effect of these stresses always continuously. We should test the transformer, right? Repeatedly every 3 months or every 6 months, right? We should repeatedly test the transformers, right? The different stress to know the health status of the transformer, right? So there are n number of tests available in the field, right, through which we can determine the current status of the insulation, right? So, right, generally in field they conduct tests very rarely, right? Once in a year, once in 2 years, 3 years, even in some stations they don't test, right? Even for 20 years also, right? One day they find that the transformer is burnt. Let's see how much loss is there, right? If you test the transformers frequently, at least 2 or 3 tests out of n number of tests, we can save, right? We can save the life of the transformer, or else we can extend the service life of the transformer, isn't it? So testing is very, very important, right? We should not leave the equipment just like that, isn't it? Because they work under different operating conditions. Definitely these conditions affect the life of the insulation as well as the life of the transformer, right? If we talk about power transformer, it's in close, right? And more than that, if there is a problem in transformer, so we have to make it shut down. So there is an interruption in power supply, right? Right, which is not our as an electrical engineer, we won't allow it, right? That power cuts, right? Once the transformer, power transformer is failed, it takes a lot of time for its replacement, right? Sudden failures. So this is right. See the importance of the monitoring, right? Very, very important. So if you talk about the testing, right, related, right, testing of a transformer, right? So there are n number of tests, right? We have chemical tests, we have electrical tests, thermal stress, mechanical stress, optical stress, right? We have chemical related tests, right? We all know that oil is a chemical, right, material, right, formed material. So we have different, we can see the various chemical properties of the oil, right? We can measure the moisture content. Moisture content means water present in the oil, right? If what, right, agar moisture, if we find the water in the oil, it did that, right? It rapidly degrades the life of the oil, isn't it? Right? Oil, right? Water, there should be no water in the oil, right? Moisture. Similarly, furan contents, neutralization value, right? So, and we also know that due to the rise in temperature of the oil, right? So we find so many gases, right? Right, so many gases are released from the oil at different temperatures. Different gases are released: hydrogen, ethane, methane, acetylene, ethylene, carbon dioxide, carbon monoxide, right? 5 to 6 gases are released from the oil. If you find the magnitude of those, right, gases, so we can estimate, right, the health of the oil on that particular day, right, based on the values. If they are all, if they are zero, so there is no gas, right? The oil is working under its best conditions, right? So we will study them later slides, right? So those tests are related to chemical tests, right? Similarly, there are electrical stress, right? We can find this breakdown voltage, right? A good insulating oil or paper have higher dielectric strength, right? Breakdown voltage, nothing but dielectric. Similarly, loss factor, right? Insulation resistance, some, right? We can do some spectral analysis also, Fourier infra spectral analysis, wavelet techniques, right? We conduct these tests on winding parts, right? Isn't it? Similarly, there are thermal tests, right? We can see the hot spots present in the transformers or any electrical machine through cameras, right? Some mechanical tests, some optical tests. So there are so many tests available in the field, right? Mainly the major stresses are electrical as well as thermal stress, right? So we should focus tests related to electrical and thermal. So chemical tests and electrical stress, thermal stress, these three tests related to these 3 points are very, very important, right? So out of m number of tests, which test is to be performed first, right? Isn't it? That's also very, very important because testing is not easy. So we have to invest we have to put some money for testing purpose. It's in lakhs or in thousands, right? It's not a small amount. Testing purpose, frequent testing we have to do. So we should classify the tests based on their importance, right? Based on their importance, we have classified the n number of tests of insulation, right? In 3 ways, right? So according to high importance is to be given to oil as well as paper analysis, right? The test which gives the results related to oil and paper analysis directly. So high importance is to be given. Similarly, medium importance is given to power factor, capacitance, excitation current, right? Similarly, low importance we can give to these basic tests, turns ratio test, leakage resistance test, winding resistance test, frequency response test, right? We generally perform these tests at the in manufacturing stage, right? At the starting of the manufacturing of these machines, right? Once the transformer is designed, they conduct general, right? There is no need to test perform those tests again, right? So we can easily go for high importance tests and medium importance tests. So high importance is to be given to oil and paper analysis. So oil and paper analysis, they generally degrade, oil and paper degrade with respect to electrical as well as thermal stresses, and some chemical tests also we have to perform. We should give higher importance to the tests related to electrical, chemical, and thermal, right? So even in these three different types of tests, so the major tests, right? I have picked some tests here, right? Some tests related to insulating paper are degree of polymerization test, furan analysis test, water content test, and tensile strength test. So degree of polymerization, we know that this chemical, oil is a chemical based, right, material. So when, as per the increase in the temperature due to different operating conditions, right, we find, the atoms of the oil, the bonds between the atoms, they become weaker, right? So we can see how many bonds are weakening between, right, due to this aging process. So degree of polymerization, furan. So simultaneously we find the this release of furans from the oil, right? Furan analysis. Next, water content. Water, right? We should also test the water content present in the paper. So, right, tensile strength, how much mechanically strength the paper is, right? Similarly, insulating oil, if you see the basic main test, most important test, right? Out of several tests, most important test related to oil are dissolved gas analysis test, right? I have discussed this, right? So this test helps in determining the various gases, right? And those gases generate at different levels, right? Some gases generate at low temperature, even in the normal temperature, 50 to 60 degrees and up to 90 degrees. Some gases may generate at produce at 150 degrees centigrade. Some other gases they produce at higher temperatures, acetylene gas, right? To find acetylene gas inside the oil, immediately we can conclude that the oil is in dangerous mode, because that gas only present at high temperatures, right? So we'll study them later, right? Next, dielectric strength, right? We all know this. We have performed this test in our basic courses also, BTech, right? It gives the dielectric breakdown voltage of the oil, right? right? How much, right? How much voltage can be applied to a oil, right? How, against, isn't it? Right, the maximum voltage that can be that can be handled by the oil, right? The maximum has electrical stress, okay, the electric stress, moisture content, right? We observe the water content in oil also, right? Mostly we observe in oil, right, as compared to paper. First we water enters into the moisture, then it enter into the paper, right? Next, power factor, interfacial tension, right? So if you perform at least 2 to 3 tests, right, out of these 10 tests, right, with the 3 to 4 tests also we can confidently right, determine the health of the oil, that transformer. Okay, so see, if you perform more tests, more data will come, right? What the doctor do, right? If you right, he suggests some test, right, for every patient, right, to every patient. So right, he first get the data, isn't it, testing data. So based on the different tests, he conclude the present situation of the patient, isn't it? Same thing we do here. If you right, if you suggest more tests, right, more money is to be invested. So if you suggest more tests, more data will come, more confidently we can take the decision. If you rely on 2 to 3 tests with less investment, so there's a risk little bit, isn't it? So testing, right, performing more tests gives reliable and accurate output, output assessment, right? Accurate assessment. So the first is breakdown voltage, right? We all know that breakdown voltage is one of the prominent diagnostic tests of transformer, right? I hope all of you are understanding the current topic, right? So we have started with the condition monitoring, right? What is condition monitoring, right? The most important parts of transformer, that is, right, insulation. The life of electrical machine, nothing but life of its insulation. So insulation, right? If you talk about transformer, oil and paper, we have seen ideal material characteristics, isn't it? Next, we have seen the aging. What is aging, right? What are the various factors which degrades the life of the insulation, right? So practically, we find aging, right? Definitely, we find aging of insulating material. So, we should know the health status, right? Frequently, we should not live just like that, isn't it? तो उसके लिए क्या क्या टेस्ट करना है, what are the various tests available, we have seen them, right? We will study one, right? Out of n number of tests, we have picked most important tests, right, related to oil and paper of a transformer, right? We will discuss them one by one. Next level is assessment, right? So breakdown voltage. So breakdown voltage test is one of the prominent diagnostic tests of transformer, right? We all know this. This is a basic test, right? In every substation we find this equipment, this breakdown voltage test. The maximum voltage that can be applied across the oil without any electrical breakdown is called as breakdown voltage, isn't it? Agar oil weak, if the oil is weak, so with the small electrical stresses, we find so many arcs. Hai na? If there is a water content in the oil, so there is a formation of arcings, which, right, which are very, very dangerous, isn't it? So the oil should be electrically strong, right? So that's why the dielectric strength should be high. For a good insulating material, oil, or a fresh insulating oil inside the transformer, the dielectric strength is 60 kilovolts. 60 kilovolt. After 20 years, 30 years, it becomes around 30 to 35 to 40. After 35 to 40 years, it becomes 25 years. So we need to check it always. We should not leave the oil just like that. One day you find the blast, isn't it? Right? So we should know the right health of that, the status of the insulation, right? So this is the basic test which we generally perform. So the procedure, right, followed to conduct this test is given in ASTM D877, right? So you can download this standard. You will get full information regarding this test, right? This is a standard procedure and right, standard reference values. Next test is flash point. This is also one of the important tests, right? Flash point is the safety property of the oil, isn't it? This test provides information about the risk of fires, right? Isn't it? So, right, if we subject to oil beyond certain temperature, right, definitely we find this flashes, right, which are very, very dangerous. So temperature, we should know the maximum temperature, allowable temperature. We should know that, right? So that temperature point comes from this flash point test. And the standard relevant standard is ASTM D93. Next is water content. We all know that the water is very, very dangerous. Generally, we use this colorimetric Carl Fisher titrator, this equipment, right? Right, we can use this equipment for the measurement of the water content in any oil, not only transformer oil, in any oil, right? And the relevant standard is B4643, right? All these testings, right? These pics are collected from NIT Hamirpur Typhoid Core Center, right? Which was inaugurated by Dr. Abdul Kalam, right? So in NIT Hamirpur, they have a well equipped this Typhoid Core Center, right? All equipment related to condition monitoring of electrical machine. We can find them in those center, in that center, NIT Hamirpur, right? So when the test is UV spectroscopy, we all know that, right? This test is very, very simple. We have performed this in our BTech level also, first year or second year in physics labs. Isn't it? What we do, we take a small quantity of oil, right? In a test tube, we put that sample in this chamber and we pass some light through that oil, right? So, and we will find the absorption coefficient, right, which is equal to the incoming light upon the outgoing light, or the outgoing light upon incoming light, right? So if you pass some light through that sample, definitely it absorbs some light, right? So there is a difference between the incoming light and outgoing, right? So we find that absorption coefficient, right? So we use that coefficient as a parameter to decide the aging of the oil, right? So if the oil is aged, right, aged oil, 30 years, 40 years transformer coil, definitely there is a right big amount of particles, ash particles, dust, right, and it is completely degraded oil, right? So definitely it absorbs more light. So the absorption coefficient is more as compared to a fresh oil, right? So we make some comparison between the fresh oil absorption coefficient and the aged oil. So such analysis we perform through this test. Okay, right? Based with respect to that comparison, we decide the health current status of it. So this test is performed according to ASTM E275. Right. So the next test is dissolved gas analysis test. I already discussed this. Right. So we keep the oil in this bottle, right? So this this red color bottle, right? So we generally, right, performing tests on oil is very easy as compared to paper, isn't it? We can collect the oil with a test tube, right, from its outlet wall, transformer outlet wall. We just simply connect the this test tube, and we will take the oil, right? Syringe, right? Syringe. So we take the oil out, and so we can test various, right? We can perform various tests on that collected sample, right? Right. We cannot perform any test directly on paper. That is not possible. We cannot remove the paper insulation, isn't it? Right. But there are some tests which gives the information related to paper, but we perform those tests on paper. We will discuss that later, right? But directly we cannot perform any test on the paper. That is not possible, isn't it? So right? That is a way of collecting the sample from the transformer, right? We just insert some test tube, test cell to the transformer outlet valve, and we take the oil out. You know? It's just like some medical treatment, what we observe in hospitals and labs. Okay. So we keep that oil sample in this red bottle, right? And we raise the temperature of the oil present in this bottle, right? Inside there is a heat chamber, right? So once the oil temperature gets raised, we find the generation of the gases, definitely, right? Whatever the gases present in the oil, they release it immediately, right? Into that free space, and those gases will move to this gas measurement chamber, this one, right? This gas detectors, they detect the various gases present in the this tube, this bottle, right? And we can find their values in monitoring, right? So this is very costly test, very sensitive test, very costly test, but the output is very useful, right? Uh, right? If you perform only this test, that is enough to decide the health, right? But the way of performing this test should be proper, right? Because a lot of precautions have to be taken, isn't it? Right? In the process of collecting the sample and putting that sample into this bottle, isn't it? It's very sensitive procedure, right? We can, right? कहीं से भी moisture घुस सकती है, right? The water or the moisture may enter at any level. Once the moisture is entered, the result will be different, right? So relying on this test is not good for accurate assessment, isn't it? We have to perform some additional 2 to 3 tests along with this. But if you perform it accurately or systematically, so whatever the result comes out from this test, that is very useful to us in deciding the health status of a transformer. Right, so this is DGA test, dissolved gas analysis test. Lot of research has been done in this area, right? So see, right, the different gases, right? These gases, 5 to 6 gases: ethylene, ethane, carbon monoxide, dioxide, methane, hydrogen, acetylene. Right, the above 2 gases they generate due to the heating of the oil, right? Right, even if there is a rise in 10 degrees centigrade, right, oil temperature, we can find these 2 gases immediately. If the paper is heated due to overload conditions of the transformer, we find these 2 gases, carbon dioxide and carbon monoxide. So carbon dioxide, carbon monoxide, they released from the paper, not from the oil, right? If you find these 2 gases through these test setup, we can find the health status of paper also, right? We are not performing direct test on the paper, but we can get the information from the oil, right? You can get the status of paper from oil analysis. Similarly, partial discharges, we know what is partial discharge, arkings, sparks, right? Same, right? जो बाहर overhead transmission line में होता है, same thing is happen between the various electrical parts of the machine, right? Even in oil also we find these voids due to water bubbles. Those voids also we find the formation of these partial discharges, which leads to arkings at further levels, plus these arkings, right? So in arcing levels, we find these hydrogen and acetylene gases. Partial discharges level, we find methane, hydrogen, right? Isn't it? So we can find all these conditions, all these situations with oil analysis, DCA test. And we can also determine the overall health status, right? According to this American standard, right? Condition, it's not mentioned here. Condition 1 is nothing but excellent condition. Condition 2 is moderate. Condition 3 is good, excellent, good, moderate, and worst. Condition 4 is worst. Right? So the different gases, right? Hydrogen, methane, ethylene. If you sum up all those gases, so that is total dissolved combustible gas, TEDCG, right? So based on TEDCG value, we can decide the overall health condition of the oil. So if the sum is less than 720, we can say that the oil condition is excellent. If the sum of all the gas concentrations that is in between 721 to 1920, we say that that is good, right? Isn't it? Or moderate. If it is in between 1921 to 4630, it is poor, right? Or low moderate. Next, it's worst case. If it is more than 4630, we have to replace the oil with new one. There's no option, right? If it is in poor mode, we can dehydrate, we can filter the oil once or twice, and we can use the same oil again, right? If it is good and excellent, there is no need to take any action, isn't it? So with only one test, we can DCA test, we can determine the various situations present in the inside the transformer as well as its overall health condition, right? Similarly, another test is breakdown voltage test of transformer, solid insulation, right? We all know that these paper insulation is very important part, because the paper only the right the paper, firstly it absorbs the heat from the winding, right? Whatever the conditions, right, operating conditions, they increase the temperature of the winding, isn't it? Right, where the heat is generated, wind from winding only. So which part is directly connected with winding? Paper only. So paper first absorbs the heat produced by the winding, from the winding, right? The paper absorbs the heat. Later, oil absorbs the heat from the paper as well as winding. The main part of paper. So we should keep a good solid insulating material, good solid dielectric. So we should test the dielectric strength of the paper insulation before the manufacturing of the transformer, before we wrap it on the winding. So this test, this solid dielectric, we generally use this test setup to determine the dielectric strength of the paper, right? Isn't it? The test is performed according to ASTM D3755, right? So this is, it's a very simple test setup. This is a high voltage transformer, right? So the high voltage जो terminals है, ये दोनों है ना, ये यहाँ पे bushings के बाद, right? These two red color whites. So they are high voltage tests, right? यहाँ से. So inside this chamber, we have oil. We place the oil, right? And there are two electrical rods which are connected with these high voltage terminals, right? So we apply the high voltage stress between the electrodes, right? So between the electrodes, we generally keep this insulating paper, right? So whatever the stress we subject to the electrodes, right? The insulating material gets subjected by the stress, right? Isn't it? So this high voltage we generally develop through this controller, right? From 0 kilovolts to up to 100 kilovolt, 150 kilovolt also we can develop, right? It's a controller, right? So this controller, step by step, we increase the secondary voltage of high voltage. Step by step, we will rise the secondary voltage, right? 2 kV, 3, 5 kV, 6 kV, right? Just like that, up to 6 kV, 60 kV. Right, and we subject the stress to the paper, right? At one particular stress, we find some punch or some breakdown in the weakest point of the paper, isn't it? So that the dielectric strength should be higher. High matlab wo weak points hai. The weak points in the insulating paper, they are subjected at that particular stress. They can bear that particular stress, right? If that breakdown voltage is higher, definitely the overall performance will be higher or good. Okay, should not be lower. So these are the several stresses, right? We have discussed major test. We have discussed paper dielectric, paper gases released from the paper. Similarly, oil gases, the gases generated, produced from the oil, and water content test, flashpoint test, BDB test, isn't it? Right? So there are so many important tests. So it's up to us, right? If you perform more tests, more data will come to us. We can take the decision right? We will compare the result, right, with the standards and ASTM. So this standard describes the right details the procedure of the test, as well as it also gives the values, reference values, right? The breakdown voltage value for a fresh sample, right, as well as the aged samples, right? And we can compare our result with those the table, right? With fresh sample, we can compare our result. How much deviation is there? Based on the deviation, we should take the decision as an expert, condition monitoring expert. We should take the appropriate decision whether the paper is to be replaced or whether right other replacement means shutdown of the transformer, or else if it is good, how many days it will work. We have to predict the remaining life also, right? Life of paper, nothing but life of transformer, isn't it? We can predict the remnant life, right? Right. In addition to the finding the current health status, we can also predict the remnant life of the equipment with all these tests. With all these tests, right? We can determine the current health status as well as the remnant life also. That some techniques, isn't it? See how much useful all these tests. Right, just 1 minute. I am getting some call. Right. So sorry for the interruption. Right. So there are various important tests. Right. We have seen all those tests. So through those tests, one can easily determine the health status, right? And he can determine the remnant health also, right? So I have discussed the tests related to transformer. Similar tests are available for rotating machines also, right? Most of discussed test can be used for the machines also. Isn't it paper test, right? In machines, we don't find oil. There are paper. So we can perform all the discussed test, paper related tests, right? So this is up to here. We have discussed the basic part of the monitoring, right? Condition monitoring. Why it's not changing, right? Right? What is condition monitoring? The materials, their characteristics, the various tests, right? How to perform those tests, isn't it? So the next part is research part. Okay. So we cannot take the samples from the transformers in case of research, right? We cannot, right? A transformer is designed for 50 years or 60 years under prescribed conditions, isn't it? Isn't it? So if you want to see the overall performance of transformer, complete performance from starting to installation to ending time, we cannot wait, isn't it? We cannot wait and observe the transformer, and we cannot perform tests repeatedly. That is not possible, right? So how to determine the performance of the transformer in a laboratory setup, right? Next part, right? Isn't it? So we perform some tests. We will prepare some type these prototypes in labs, right? Transformer prototypes, right? And we subject the oil and papers with respect to different operating conditions, thermal stress, electrical stresses, major stresses. And we will collect the samples. We follow some procedures, aging procedures, right? So repeatedly we collect the samples and we perform the detailed discussed tests, and we will see the variations, right? This is what we do in lab, right? Whatever the outputs, whatever the results we get, whatever the conclusions we made from this analysis, right? And we apply to the field also, isn't it? So how to perform the tests, right? So accelerated test. It's not simply test, it is accelerated test. So what we do, right? To prepare the test samples, first we should pick this, right? Paper as well as oil, right? As well as copper also, right? So these three are the main three parts in transformer, right? We have paper insulation, we have oil insulation, right? And and the properties of oil and paper gets varied a little bit with respect to copper also, the winding present in the oil, right? So core aging is very, very less as compared to the other three main parts, that is winding, oil and paper, right? So there is no need to consider the core material, right? The remaining main materials are oil, paper and copper. We can collect them, right? So this is a craft paper which you use in transformers. So this is a mineral oil which we generally place in transformers, right? And this material, this copper material, right? We know this, right? So the quantity of these materials, right, is selected according to the standard, right? So this is IEEE standard C57 154 2000. So this is the standard, right? After performing n number of tests and with a wide observation in the design of transformers, right? They have researchers across the world. They have listed some guidelines. How much copper is collected, how much oil is placed in the transformer with respect to its ratings, how much paper is considered, right? So these values are given in the this standard, right? So we prepare the samples with respect to the guidelines given in the standard. It's not like that I have taken some material, I mixed it in some oil and some copper is also dropped and I do tests. It's not like that. There should be some standard procedure. The ratio of oil to paper, the ratio between copper to oil, copper to paper, right? Those values we should collect from the standard, right? Isn't it? And same ratio, we mix the samples and we put them in the this furnace oven, temperature oven, right? And we know that we have discussed this, right? So temperature, thermal stress is the main stress which degrades the life of the oil as well as paper, isn't it? Temperature rise. So in temperature here also in labs also we do same thing. We rise the temperature beyond 100 degrees, right? At 120 degrees, we will see the variation in different parameters, right? Similarly, we subject the sample with 140 degrees centigrade, we will see the variations. At 160 degrees centigrade, we'll note down all the parameters. Isn't it? We fix time. We age the sample for 24 or 48 hours. We fix time. That time is also given in the standard, right? Right? Generally, the transformer insulation is designed for 60 years, to work for 60 years at a temperature of 90 degrees. At a temperature of 90 degrees. And this standard also discusses the other temperatures also. At 120 degrees, 48 hours. 150 degrees, 24 hours, like that, right? But in practically, we never observe 150 degree, 200 degrees centigrade. But in labs, we can develop such setup. We can see the real performance of the insulation under such high stresses, right? So that is what we are doing here, right? So increase the temperature and fix the time according to the standards and collect the samples, take the samples properly. It should be properly sealed, isn't it? These rubber corks, right? And perform all the tests, whatever we discussed, right? Note down at 120 this point, 160 this point. Make the graph. For a fresh oil, you know the value, right? For aged samples, you can note down the deviations, right? And apart from this thermal stress, we also know that electrical stress is another important stress which we have to check, isn't it? So for that, we have created one model, right? Prototype transformer, prototype for transformer, in which we can rise the temperature of the oil and paper as well as the electrical stress also. So the electrical stress generally present between the two electrodes, right? So here I have considered two electrodes. The copper is picked with respect to the standard, and this paper weight is also picked according to the standard. The quantity of oil is also taken according to the guidelines given in the standard. So these materials, oil, paper, this copper, right? The ratio is as per the standards. So here what I did, I have collected two electrodes and there is a insulating paper, right? And these two electrodes are subjected with high voltage transformer. That I discussed this in solid dielectric test, right? So that with that setup, we can apply the high voltage test. So the paper hai, these two electrodes are copper electrodes are insulated with this insulating material, solid paper, right? Isn't it? So whatever the stress we apply to these electrodes, right, the stress is applied to this insulating paper material. Definitely it loses its properties with respect to electrical stress. Similarly, it loses the paper as well as oil loses the properties, operating proper performance with respect to temperature rise. That here a simple heater is connected with the supply, right? And we can control the temperature with respect to some controller, PID controller, right? So this is the test setup we have. I designed it during my PhD, right? So this is the controller circuit, and according to the standard, the various materials used in that prototype are given here. So this is the lab setup, right? This is the test cell transformer prototype, and these two are high voltage, right, cables, high voltage transformer through which we can give high voltage test. We can apply high voltage test between the electrodes, and this is the controller, temperature controller, right? It controls the temperature of the oil, right? Heating coil, right? So we can here I did only two. I have considered the only two stresses. First is thermal stress. Second is thermal and electrical stress, combined stress. We have other stresses also, right? In initial slides we discussed climatic stresses, environmental stresses. That work is still pending. Any one of you can address that. The upcoming researchers, right? The more stresses we can include, the more realistic, right? Case studies we produce, isn't it? Here I have designed the prototype with respect to two major stresses present in the electrical transformer, right? Electrical machine. So if you observe the curves, see here, right? So there I have considered three materials. One is TUK, which we generally use in transformers, and the two other materials, the recent developments in dielectrics, solid dielectrics, that is Nomex 910 and Nomex 410, right? So if you see the variations in dielectric strength, so this red line, right? So this line represents the variation in breakdown voltage related to TUK based sample. In another sample, I have inserted this Nomex paper instead of TUK. But yeah, right, it has given a good result compared to TUK, right? This one, blue color line. The third one is green color line, isn't it? Right, in TUK Nomex 910, Nomex 410, Nomex 410, Nomex 910 gave the good result up to 160 or 170 degrees centigrade. After that, right, the reduction is very fast, right? The performance is poor after 170 degree. But this 410, its properties are good even at higher temperatures also, at 220 also. So such analysis we can do in laboratories, right? So here I have shown only two parameters results because we have many things to discuss, right? Isn't it? So like this, we can work on the prototypes, right? In real field, it's not possible, right, to test the transformer, and we cannot generalize it. If you consider only one transformer, if you observe that performance of that transformer, it's not that much good research, because we are focusing on only one transformer, and the transformer subjected to some certain conditions. So the analysis, whatever we get, that will be subjected to that particular transformer. So we cannot generalize it, isn't it? So we have to go for this kind of setups, right? So realistic cases, right? So we have seen the developments, right, in the transformer condition monitoring methods, and how they are, how we do the analysis in laboratories, research. We have gone through this, right? Now we will go to the assessment part. So it is okay. We understood what is to be, what kind of tests are to be preferred and how they are conducted, and and we also know that how to generate, produce the prototypes on how to work on the various materials, right? That is okay. But the second thing is, another important thing is how much accurate our analysis is, how much reliable our work. That is another part, right? It's not like that I have collected some material, I have done some testing, I got some result, isn't it? And I will generalize this, right? It should not be like that. There should be some accuracy analysis, or there should be some reliable tests, isn't it? What is happening in general, right? For reliability purpose, we go for n number of tests. The more tests we conduct, the more reliable the output is, isn't it? Relying on one or two tests is not good, right? Suppose the right, if there is a mistake from the person who is performing the test, so suppose if there is a problem in sample collection, or else if there is a problem in test setup, whatever the situation, you will get wrong result. Wrong result lead to wrong decision. Wrong, there will be a loss, financial loss to the customer, isn't it? So we should not rely on 2 or 3 tests. We should go for at least 10 tests, more tests, for more reliable output, accurate output, isn't it? So when we collect 4 or 5 tests, when we conduct 4 to 5 tests, these tests, right? So there will be a problem. What is that, right? Suppose, see, if you perform all these 10 tests, suppose think that DGA test is giving a good result with respect to dissolved gas analysis. All the gases are in their good condition or excellent condition. Maybe due to some electrical faults, its dielectric strength may become weaker. So this test is giving that the condition is poor, and maybe there is a possibility of moisture. Maybe it is moderate, and this furan contents, maybe it is good, excellent. So different tests give different results with respect to their operating conditions. It's not like that all tests give same result. Even in medical field also, doctor suggest 4 to 5 tests or 10 tests, whatever it is, depends on the case. And we don't see all tests in same manner. Most of the cases, in some cases it is okay, they get good results. But in some cases, some test is good, LFT, some other test is poor, right? Isn't it? Like just like that. Here also we observe same thing practically, field, right? So different tests give different. Suppose if it's a healthy transformer, all tests comes good or excellent, then it's okay. Or else if the transformer is completely degraded, we get all the testing reports as worst or poor. In such cases also it's okay. What about the transformers, right? Moderate life transformers. They are working under different conditions, climatic stresses, electrical stresses, overloaded, lightly loaded, chemical stresses. Definitely there is a change in the reports of these tests, right? So when we get the different reports from different tests how to take decision, right? That is also very, very important, right? So we should suggest some action, remedial action to the engineer, field engineer, or some JE, junior engineer. Appropriately, he will do the necessary things. So that output, final conclusion should be exact and appropriate. So based on the obtained data, it is difficult to take the decision. One test is giving good result, one is poor. In some aspects, the oil is good, some aspect it is poor. But the actions are very limited. Either we have to filter the oil once or twice, or we have to replace it with new one. Only two options. We don't have much remedial things, whatever we observe in medical field, right? There are so many remedial actions. But in case of transformer oil, whether you have to filtration के लिए भी निकालना पड़ेगा. We have to take the oil sample out, oil out. So and that filtration time, the transformer is in shutdown. Or else we have to replace it to new oil so that the life of transformer will be extended. Oil due to oil, we cannot completely remove the transformer. If there's a problem in oil, we have to replace the oil, not complete transformer, right? There's a financial loss, isn't it? So actions are very limited. So we have to take appropriate decision. So in conventional methods, by seeing the reports, it is not possible to take the appropriate decision. Conventional method. But for reliability purpose, we have to go for more tests, more observation, more reports, more observations, more conclusions can made. The less tests, less reliability, more chance for wrong decisions, isn't it? So that's why we have to go for some advanced techniques, neural networks, AI techniques, fuzzy logics, genetic algorithms, right? See the latest trends, right? This FDP is also mostly and latest trends, right? In electrical field. So this is one of the area in electrical streams, right? Monitoring, condition monitoring of every electrical machine. So in this field, we have latest developments, different, right? In determining the health status as well as the fault present in the machines, any electrical machine, transformer or rotating machine, right? So definitely these AI techniques can solve our problems, right? Which are present in conventional methods. Conventional methods are helpful in particular cases, right? Suppose if for a healthy transformer, newly installed transformer, or old transformers, right? Most of the out of 10, 7 to 6 to 7 tests, they give same result, 4, 4, 4. Based on those reports, we can take the decision. But what about moderate transformers, right? We cannot take appropriate decision. So we go for AI techniques. Here I have discussed only one technique, that is fuzzy logic based health assessment, and the rest of the techniques you can go through, right? There are a lot of literature is available in that, IEEE and IET, right? So how the our problem is solved with the fuzzy logic technique, that I am going to discuss. Okay, how this AI technique will help us can solve our problem, right? We have problem, right, in determining the health status, right? We have confusion is there, ambiguity is there, a big confusion was there, isn't it? So we, for reliability purpose, we considered more tests. But when we consider more tests, it is very difficult to test appropriate output, right? Appropriate decision. That's why we are using this technique. How this can solve our problem, right? We will see here. I take a small example, right? Isn't it? Right? You can correlate this, right? How this technique will help us, right? We have discussed our problem, right? Same problem. One small example I will share so that you will get more confidence about this thing. Right. So fuzzy logic, simply one small example how the fuzzy logic where we can use this fuzzy logic, right? Technique in what cases exactly. Suppose there are 3 to 4 friends, three friends. They visited some restaurant, right? Right, isn't it? So they had some lunch, right? So they have right. They had some lunch. So finally they have to give some tip to the person, right? So first person gave 10 rupees, second person 20, third person gave 50 rupees, right? The thing is, the three friends visited the same restaurant, they had the same lunch, but the output, that is tip, they, right? It's varied, right? It got varied. How? So the three people, if you consider the inputs, right, which are common to the three people. So inputs you can consider it as the quality of the food, the price of the items, and the service, their service, right? Based on these three inputs, right? They have decided the tip, output tip, right? So the three inputs are same to three people, but the output gets varied, right? So the output depends on their satisfaction levels. First person is thinking that all are poor, or one is good, one is poor. Based on that, he concluded, Acha, I have to go only 10. That's it. Second person 20, third person 50, right? So what about fourth person? A new person entered into the same restaurant. He also had how much tip he has to give. Of course, he will give some amount, but there is no some standard system. Confusion is there, ambiguity. If you generalize, if you produce a model through which we can put our input satisfaction values and we get some tip value, exact value, isn't it? If you produce or develop some mathematical model, give your three inputs, food quality, many itna value out of 0 to 10, this is the food quality value. 0 to 10 price, this much. 0 to 10, the service rating, right? Rating value, this much. So if you produce a mathematical tool, it will give some output. So you give that exact tip. So the standard, particular, no confusion, right? In field, isn't it? So those satisfaction levels, I know you put them in terms of rules. If input one is this, input two is this, input three is this, this is output. If input one is all are good, output is high. All are poor, output is low. वो भी value के साथ, isn't it? A simple model. In field also, we have 5 to 10 or 3 to 4, whatever it is. You take selected inputs, you correlate the outputs, the input. So for the correlation, we should have a proper understanding about the system. We should not simply close our eyes and framing rules. It's not like that. Technically, you should understand each and everything. If you are going to address a technical problem, right, each and everything, you should have knowledge how the machine behaves under this particular situation, what would be the output, because it's an expert model. So you should create the rules as an expert, right? So you should know the performance of the machine under every case, every rule. Otherwise, the wrong formation of wrong rules leads wrong result. Formation of exact rules, realistic conditions. Right? If you form them in terms of rules, real output you get, isn't it? So same restaurant case, we are subject to our problem. Transformer tests. There are 5 tests. Output is unknown. I'm not unable to determining the output. So frame some rules between inputs, outputs, input conditions को. जैसा ये restaurant में ना, if quality is good, service is good, price is good, that is one rule हो गया, right? Price is high, tip is high. That is first rule. Similarly, quality is good, price is high, that service is poor, some moderate tip, and just like conditions. Similarly, here also you divide the inputs in different modes: good, moderate, poor. They are membership functions, right? They are membership functions. And you correlate this. Similarly, output also. Restaurant mein na, low tip, high tip, moderate tip. Output membership function. Here also you decide the output health condition, health index, transformer health index, moderate, excellent, poor, excellent, moderate, poor. 3 membership functions. So input membership functions, 5 inputs. In every input, 3 membership functions. Good, poor, right? See, 5 power 3 input combinations. Output, only one output, 3 membership. So you see how many rules can be framed, right? If you consider all those cases, definitely the model will be a reliable model. If you want to go for reduction of the combinations, you should have proper knowledge, right? Expert rules. Definitely we have to reduce. More rules become more complex, right? More time it takes execution. Less rules, expert rules, but those cases, all those reducer rules would be realistic cases, right? Like that. We do the same thing in fuzzy logic models, right? Isn't it? Now you can understand this clearly. So there are 5 to 6 gases, right? Here we observe, right? Same problem, right? First understand the problem. First understand the problem clearly. And also study some technique. See the suitability of the technique to all the problem, right? Here see the right, there is a great suitability between the methodology and the problem. And just apply it, right? Especially for the freshers, those who are doing MTech and BTech projects, for them it's very helpful, this session especially. PhD, they all of them know all these techniques, I hope, mostly. So there are 5 to 6 inputs, right, gases, and they are right according to standard. The conditions are decided, right? One is good, excellent condition. If the value of hydrogen is between 0 to 100, we consider that it is an excellent condition. Hydrogen gas, excellent mode mein. Similarly, good, poor, worst. If hydrogen value is greater than 1800, it is worst, right? Similarly, the other gases. See, for a good oil or excellent oil, all the values for all the gases, right, present in first mode, right? Excellent mode. For a moderate transformer, assume some transformers. For some transformers, if all values present in second range, we can say that it is good or moderate. If it is in third range, poor. If it is in fourth range, worst. So in 4 cases, we can confidently tell the health status of the oil. Good, excellent. But in practically, this is not possible. 99 cases. Suppose hydrogen may be in first range. C2H4 is in third range. C2H6, acetylene, it may be in first range. Hydrogen is maybe in fourth range. So different ranges, different gases, different inputs, different levels, different inputs, different satisfaction levels. Restaurant case, right? Same problem, same thing. So there also we cannot get the reliable output. So definitely you have to put them in terms of memberships and correlate them with output and get the right. So here, right, so there are 4 ranges, right? So here I have considered them, right? Instead of 4, I have considered 5 for some other reliability purpose. So better you can assume them as only 4, right? Because in standard there are only 4 ranges. We cannot say simply take these values just like that, right? By our own choice. So we should consider these limits from the standard only, technical standards, right? So from standards only, I have picked these membership ranges, suppose, right? And right, so instead of 4, definitely there should be 4 ranges, right? So there should be 4 membership functions. But instead of 4, I have considered 5. That is to get some more output, right? Realistic output. Instead of 4, I have considered them as very bad, good, very good, and excellent. 5 input membership functions के हिसाब से 5 outputs, excellent, very good, good, bad. The output actions will be remedial actions will be different for these 5. Right? There is some improvement with respect to previous models, right? So these 4 models I have right put them in terms of membership functions, right? Okay, isn't it? So there are overlaps between 2 membership functions. Definitely we require them, and you all know that the advantages of overlaps. Right? Suppose think that suppose if the hydrogen gas value is assume that for a particular transformer sample, suppose the hydrogen value is 701, or 702, sorry, 702. So though the value is in third range, but it is very near to this second range, right? 702 is very near to 700, right? So we should not take the decision with respect to T, right? Poor condition ki, the output decision with respect to poor condition is different. The output assessment with respect to good condition is different, right? So we should consider such values in both the cases, good and poor. Okay, so such things overlaps. Okay, so you just put them in terms. So you should have some basic idea about this fuzzy logic, right? How the membership functions. So membership functions I have discussed. There are different types of membership functions, right? Rectangular, trapezoidal, Gaussian too, right? So you select one type of membership functions which suits your input data, right? Similarly, you decide output with your own choice, right? Here output आपके hand में, you can decide it. So I have decided it as 0 to 1. If the output is 0, so I conclude it as very bad. If it is right in between 0.5, right, it is good. It is 1. If it is 1, I can tell it as excellent. So now the input membership functions, output membership functions are formed. Next, you correlate them, right? So 5 input. In every input, there are 5 membership functions, and output is there. In output also, there are 5 output membership functions. Next step is fudgification is over, right? In fuzzy logic, the output assessment through fuzzy logic techniques involves 3 stages: fudgification, fuzzy inference, and defudgification. In fudgifications, we form the input membership functions, right? And the crisp input is converted into non-crisp, right? The DOM, right? See, fudgification, right? So these are the inputs, right? So you consider only for understanding, you pick 2 inputs. So hydrogen value is at 925. Suppose 925 value cuts this medium range, right? So it has a DOM of 1, degree of membership. Degree of membership is the inputs are detailed in terms of its degrees, right? 925 is in medium range, and what is its degree between 0 and 1? It is at 1, right? If it is 850, suppose 700, यहाँ पे देखिए. Suppose or else if it is at 620, so 620 value is in medium range and its DOM is around 0.75 or 0.8, right? Medium range and degree kitna hai, how much severe it is in medium case. In medium condition, how much medium it is, low medium or high medium, moderate medium, right? 0 to 1 degree, right? Understand, you just study some basics of this fuzzy logic technique, every technique, whatever you choose, right? We will get more idea. So the crisp inputs are converted into non-crisp, right? And that is in fudgification. In fuzzy inference system, we frame the rules. Rules means the correlations between the input membership functions and the output. So in the design system, how many inputs are there? 5. In every input, how many membership functions? In every input, how many membership functions? 5. So how many input combinations you can frame? 5 power 5, which is more than I think 5,000, right? So more than 5,000 cases I have to frame. In every case, there is some defined output, right? So this is what we have to do, right? But here we have used some logic in reducing the rules, right? The more possible cases, practical cases we considered in our fuzzy inference system. And here I have reduced more than 5,000 rules into 31 rules. Okay, I have followed some logic, right? Some rules reduction. The more possible cases I have considered. Okay, So in your problem also, you just see the more possible cases. If all are good, actual output is good. Agar in out of 5, if 4 are good, definitely output is good. Okay, no need to consider that case, right? Such cases, right? So suppose for a sample, so these are inputs, and all our inputs are in medium range, right? One example for understanding purpose I have shown here. And their DOMs are at different levels. First input is 1, second is 1, third is I think some other value 0.95. And acha, this is also 1, and this fifth one is having 2 memberships, right? Right. So definitely, right? So according to the given set of inputs, the output is good membership functions. And it's truncated, right? It's a truncated membership functions, and its value is 0.953, right? 0.953. So here I have used maximum minimum fudge inference method. So in such method, we will get the truncated membership function at its minimum cut, right? You will go through these methods, right? Each and everything is not possible. There are many things to discuss, right? You go through this method, how maximum minimum method, some other methods will go, right? Some other methods as well. So once the output is determined, still it is a output membership, right? It's a truncated membership function. So we didn't get any value, crisp output. So to convert this truncated membership function and to get the crisp output from this truncated shape, so we have defudgification method, start stage. Here we use center of gravity method. So we find the centroid of this truncated curve, right? The shape. So here use this formula, right? For that. For uniform shapes, we can find for square, rectangular, triangular. For such shapes, we can find centroid very easily. For this Gaussian shapes, it's not easy manually, right, to determine centroid. So use these formulas. In default options we have in MATLAB, right? So here it is 0.446. So, right. So with respect to this value, the output condition is good, and its index is 0.446. Right. See, in conventional method also we find the same case. If all are in medium range, the output will be good, isn't it? But in conventional method, we don't find the index value, this value, right? In moderate also, suppose it is a point, suppose it is 0.65, right? If it is 0.64, so it is very nearer to poor case. Such case we don't find in case of conventional method, right? We tell the operator, we suggest the, right? We will take the decision with respect to good output only. But it is very nearer to poor if it is at 0.62. So these techniques also avoids the risk involved in the assessments, right? It determines the health condition as well as it also determines the index. It avoids the risk. It improves the reliability. It avoids the ambiguity or the confusion present in the conventional methods, right? So one technique I have discussed here, right? One small techniques. So one example I picked, right? So you apply the same technique for n number of samples, 50 samples, whatever, right? So here, right, that is the way of solving the technical issue with the advanced AI technique, right? Just 1 second. Yes, right. So sorry for the interruption. Actually, due to this financially rending, doing lot of works. The gem coordinator here. So some works are coming. Right. So that was the technical problem, and addressing that problem with the AI technique. With neural networks also, we can solve such issues. Genetic algorithm techniques. There are many techniques, advanced latest trends, right? Go through the literature. First know your problem and the technique, suitability of the technique with the problem. And additionally, you should take care of reliability issues, accuracy issues, and the highlights of the approach, right? Whatever we do, that should be fruitful to the field, right? Isn't it? There should be something novelty in the research, right? So here what we did is right. So here based on the oil gases and their quantities, we have determined the index, right? DGA based index here, right? So in addition to this analysis, I have considered some other tests also, tests related to oil, that is water content, acidity, BDV, dissipation factor, right? No major important test based on the only oil gas concentrations. Output assessment is not reliable. Only one test and its values getting output, deciding the final action is not good, right? That's not reliable. So instead, in according to that important test, most important test, I've considered some other tests as well, 4 to 5. So here I have determined only oil health index. Next important part is paper, right? So we know these two gases we can observe in DGA test, CO, CO2, and they details the information about the paper. And we have furan analysis test, right? Furans are released into the oil once we age this sample. Once the temperature of the paper gets raised, uh, isn't it? Once the paper loses its thermal properties, it releases some furan contents, 2 furan for fural aldehyde, right? 2 FAL, 3 FAL, right? And we can observe those furan particles from the oil, in the oil, right? We can perform this furan test on the oil, and the information which comes from out from the test is related to paper, right? So we do test on oil only, but the information is of paper, right? So here I had decided, I have determined the health condition separately for the paper, and I have mixed oil health condition and paper health condition. I have decided the total health status, right? Isn't it? So determining the health status is not only our job. It is good, worst, poor, excellent. It is okay. So what type of problem is present? Fault present in the transformer, which we generally call it as incipient faults, isn't it? So what type of fault is present? Whether it is a low temperature fault, medium temperature fault, high temperature fault, yeah, partial discharges, arkings, low arcing, high arkings, yeah, burnings. What type of fault it is, right? We should also determine that in severity of the fault, type of the fault, parallelly the health status. Then only it will be a exact analysis, right? We should reduce that fault, right? Isn't it? Then only we can improve the performance of the machine, right? Isn't it? Taking decision only on health condition, ignoring the fault level, it's not good, isn't it? Right? So for fault analysis, there are many techniques. Faults present in paper and oil. There are some conventional methods. In those methods also we find some problems, and we go for AI techniques again. Here I have shown one method. Similarly, induction machines, they're also, right, after performing tests you get some problems. Right, for every analysis we have conventional techniques, standard methods, and we have problems also in standard methods, and solve them with latest methods, right? And you can pick different materials, different insulations for a best machine, to produce a best machine, right? So time is very less. I will right, want to put the time on discussion part, right? 15 minutes. Otherwise, there are many things to discuss. So, but the overall, I have discussed, right, how this problem is addressed. These slides tells the same thing, right? different models, right? Earlier we discussed this. Next, this model. Next from here, these small model CO, CO2, right? CO, CO2 to FAL. Right? So this is also taken from standard given in reference. This IEEE standard, right? So definitely, right? There should be some authenticity for the values also. We should not consider by our own choice. Either standards or some references, standard references, right? So after finding the oil health status as well as paper health status, the overall health status, right? जो outputs है paper and oil का वो दोनों combine, right? I have combined them in a single model. That is a total health index. This one, right? Oil health index, right? Right. So that is the health status part, and second part is right here. Actually, time is less. Otherwise, I would have discussed this. So here, what I have discussed, so I reduced the more than 5,000 rules into 31, right? Isn't it? We have used some concept and some logic, and we reduced 5,000 plus rules to this smaller number, 31. Though there is a logic, but if you see it practically, that's not good. That's not 100% reliable, isn't it? Maybe reliable up to 95, 90%, 85% reduction with reduction of rules. You consider all cases, that is 100% reliable model, isn't it? Till यहाँ पे भी कुछ problem है in AI techniques also, right? So to reduce the complexity issues and this reliability issues, to meet these issues, we have developed some another model. It was published in IET, right? These attributes, right? Some technique we have followed. Instead of considering all the inputs in single model, right, like this, we have grouped them into different categories, right? So all gases, one group, other tests, and another group, third paper tests, third group. So here we have used some multi-regression, multi-criterion analysis. You can download this paper and go through this, please. So what I did, I have reduced 12 number of inputs, 12 inputs into 3. यहाँ पे category बोल रहे हैं, right? I am calling it as category. So using this multi-criterion analysis, all the inputs are considered and they are divided into 3. That is possible, right? You go through that methodology, which is detailed in the paper. So now I have reduced this 12 into 3. So now 3 inputs are there. In every 3 inputs, there are 4 membership functions, right? So how many combinations? 3 power 4. That is 3 power 4 means 981 rules. 3 power 4, 64, sorry, right? 64. Sorry, 4 power 3, sorry, n power m, 4 power 3, right? 4 power 3, 64 rules, 64 combinations will form. So, right, 64 is not very tough. So we can consider them all, right? So see, all these, see, with the 3 inputs, reduced inputs, 64 rules, all cases are considered. So reliability, accuracy issue is solved. And for reliability, all the tests are considered. It is also solved, right? So here I have used some method. You can create some new model with some other techniques, which is better than this, right? It's a continuous process. We're also working on some other models these days, right? So here also for incipient faults also we have different methods, right? So many things, much time, right? So you please download my papers. You can understand them easily, right? You can determine the faults also. Here I have discussed one, right? There are different methods, IEEE methods and IEC methods. So through these methods, we can determine the fault. So these methods are detailed based on the gas concentrations. Whatever we get the gases concentrations from DZA test. So those gas concentration values, the people across the world, researchers, they have developed some basic methods and they become very standard these days. Even in field, the the field engineers, they follow these methods to determine the fault. but each and every method has some problem, some drawbacks. Right here for right within 5 minutes, I will observe one small, right, one method, only 5 minutes. So this is one of the method, IEC method, right? This is IEC method, IEC ratio code method. With this method, how the incipient fault is determined. That is the object. Okay. So first see, there are three inputs in this method: x1, x2, and x3. Whereas x1 is h4 by h2. Right. These values comes from DGA test. We pick the sample, right? We collect the sample from the transformer. We perform DGA test, and we get these values. That is clear, right? X2 is C2H2 by C2H4. X3 is C2H4 by C2H6, right? So determine these three values, x1, x2, x3. So if x1 is less than 0.1, you take it as code 1. Similarly, if it is 0.1 to 1.0, code 0 is proposed. If it is 1 to 3, right, definitely x1 exists in one range. So you just select the corresponding code, right? Note down that corresponding node. Similarly, x2, note down this corresponding code. x3, note down that corresponding code. So x1, x2, x3, after determining x1, x2, x3 with respect to these three ranges, we will have three codes, x1, x2, x3, right? So for a small example, suppose for one sample, if x1 is 0, x2 is 1, x1 is 1, x2 is 2. Suppose x1 is 0, x1 is 1, x2 is 2. In conventional method, the fault is no fault. Suppose I did see this table. If the three codes are zeros, 0, 0, 0, then no fault. The three codes are 0, 0, 1, then it is very low temperature fault. 2, 0, 0, like that, isn't it? So in IEC code method, the different faults are defined, isn't it? With respect to the generated codes, we can determine the fault directly with that standard, IEC code method. We can determine this fault directly, right? This is given. But there are some codes, some code combinations, right? इसी में, which are not defined till date. Suppose if x1 is 0, x2 is 1, x2, x3 is 0, the fault for this code is not defined. Similarly, the other codes. Why? What is the reason? The reason is there are multiple faults. There are not only one fault. There is a partial discharge fault, there is a arcing fault, there is a low temperature fault, mixing of faults. There is not only one fault. Single faults are defined by the standard methods, but multiple fault cases are not defined. So there is a problem in conventional method. So we can solve this. So, right? So if you create some model between inputs and output, definitely at each and every case, we get some output. And that output may be related to some multiple fault cases also, right? How the model is designed, what is the basic theory behind the formation of input memberships, output membership functions. We please go through the papers, right? We will not discuss that. So that for the such undefined faults also, we can determine the output, right? For those cases also, we can determine the fault. See these blue colored, right, samples are related to these multiple cases. So here out of 24 cases, 1, 2, 3, 4, 5 cases, in 5 cases, the conventional method gets failed in determining the output. The confusion, nobody can tell the output, but here you can tell. But the problem is in here also, it tells only one fault, dominant fault. One index, definitely one fault. It cannot determine two faults. That is the problem still present in the AI techniques also. Conventional methods have their own problems. Advanced methodologies have their own problems. So it's a continuous process. We develop new models, right? So maybe another person, some person may propose a new model which can address all these issues, right? So these things. So there are n number of artificial support vector machine learning vectors. genetic algorithms, genetic programming, different methodologies. Right? This is the latest trends, right? That's why I have picked all these areas. Right? I hope this session is helpful to upcoming researchers. Right? Now I want to know the queries, right? It's right. Yeah, if you have any doubt, we can clear them, please.
Hello, sir.
Yes, yes.
Sir, here we have some questions from participants.
Yes, yes, please.
So first question, sir.
Hmm.
Can we implement ANN and fuzzy logic techniques for testing of transformers?
Yeah, sure, of course. Why not? A lot of research has been done in that area. With the neural network, with fuzzy logic, different techniques, and combination of fuzzy neurosystem with the problems. Lot of research has been done. Please go through that and see in every research we find some short gaps, right? And try to address them with some improvement. It is possible, and and there is a lot of literature available on that particular topic. Yes.
Okay, sir. One more question, sir.
Hmm.
DGA method is mainly detect which type of faults?
DCA methods generally detects in all incipient faults, right? I just now I discussed that. So all the conventional fault methods, these IEC ratio code method, dual triangle method, Dornan method, right? If you see the literature, you find some basic methods through which one can determine the fault present inside the transformer, incipient fault. Outside transformer faults, we know line to line, line to ground, three-phase faults, short circuit faults, we know them, and they affect the life of the insulation, isn't it? Right?
Okay.
Insulation and we find some fault development, right? Generation of some developing some new faults, internal faults, right? So these DGA methods mainly discuss about the faults present inside the transformer, right? And DGA test, based on DGA test result, we have some standard methods, right? Standard methods are described, right? And we have problems in each and every standard method, and we try to address them some latest techniques, right? But we should take care of all issues, accuracy issues, reliability issues, and novelty things, right? Isn't it? We should take care of each and everything. Yes, next.
Sir, next question, sir.
Hmm.
Is there any advanced method to detect faults over DGA method?
Advanced methods we cannot tell just like that, right? You see, all these methodologies are advanced methods. See here, right? This fuzzy logic, neural network, support vector machines, right? Learning machine. See, in latest techniques also, these methods are have their own limitations. Just like I discussed one case, that fuzzy logic. If we right, if I want to go for complexity issues, reducing the complexity issues, the rules became less, but somewhere accuracy is missing. For that, to address that problem, we have incorporated some multi-criteria analysis along with the fuzzy logic, right? So we have to take care. We have to solve the things with using multiple techniques or some other ways, right? Definitely. But we cannot specify only one technique is best. It's not like that.
The next question, sir,
Hmm.
from the participants. So what are the advanced topics in power transformers?
Yeah, that's what we discussed today, right? These all advanced. First thing is in India, very less research has been done in this condition monitoring of electrical apparatus, right? In this particular area, very few back faculties are working in this area. Very few researchers. Kulkarnis are in IIT Bombay, Sadis are in IIT Madras, and Nidhi Madam in IIT Kanpur, and four to not four, even 3 to 4 faculties in some various NITs, and some persons they are in foreign these days. They worked on some this area in India a few years before. So there are limited people who are working in this area. this condition monitoring area, right? Isn't it? So there is a lot of scope to work in this area, this diagnosis part, right? We can monitor we can focus on diagnosis part of transformer, electrical machines. Nobody did these works in India, right? See, country to country also this research varies. The operating conditions in India, even in state to state, in Andhra, the climatic conditions are different. The loading conditions are different. In Jammu and Kashmir, climatic conditions are different. Atmospheric conditions, loading conditions. Punjab, different, right? Isn't it? Delhi, it is different. So different operating conditions, different performances, right? There's a big area. It's a big area. So in if you talk about monitoring techniques, methods, they are common. Whether it is America, India, any state. Methods are common, but the operating conditions are different. So we should focus on operating methods, not only methods, operating conditions. So we should focus on developing the models with respect to these conditions. You create such atmosphere with all the conditions and subject them with the insulation aging, right? And test them, extract the data from the insulation with respect to different conditions and use advanced methodologies for health assessment as well as remnant health assessment. See how much wide the area is, but very few people are working in this area, right? So I suggest the upcoming researchers, especially MTech scholars and BTech scholars, that this is a core area, right? If you go any industry, you have to work on transformers, industrial motors, right? Right? It's not only power system, dispatch, all these things, controllers, power electronics. Right? This is also one of the major area, but very few people focused on this till date, right? So I suggest the young researchers. It would be a great area, right? Next.
Yes, sir. Thank you, sir.
Yeah.
You have answered all our questions.
Okay. Thank you. Thank you for that. And one more thing is, I just want to share one project is sanctioned recently to me from DSIR. So I am looking for a good student, right? Who can address all the objectives. He or she, right? They can apply for that project, right? Please go to our website and right under jobs column, you can get that advertisement and you can apply.
Sure, sir. Thank you, sir.
Yeah, tomorrow is the last date for that application. Please remind that. Yes. Yes, that's it. If you have any queries still, you can ask and or else we can conclude.
No questions, sir.
Okay, thank you.
So we will close this session with a vote of thanks. On behalf of EEE department, I thank Dr. Rangaraju Chilaka Garu. We had a wonderful and informative session, sir. Thank you, sir, for accepting our invitation. Also, I thank each and everyone for your active participation. I request all the participants to join for tomorrow's session. Please make use of all these informative sessions, and as a faculty, it's our duty to pass on it to our next generation. Thank you all.
Yeah, thank you, Parameshwar sir. I once again thank you each and everyone.
Thank you, sir.
Right, coordinating this FTP, fruitful FTP, and I hope that today's section is helpful to all the participants.
Yes,
Thank
sir.
you, sir.
Thank you, sir.
Yeah, thank you. So can I leave?
Yes, sir.
Yes, sir. Thank you. Okay.
Hello. India, sir.